students, very good morning. This is your mathematics class. Today we will do some example of your circle chapter depend on theorem. So look at the board. That is, recall that two circles are congruent if they have the same radius. We all know that if two circles having same length of radius, we can say that two circles are totally congruent because both have same length of radius. We know that. So depend on this theorem, we have to prove that equal chord of a congruent circle subtend equal angle at their center. So depend on this, we have to prove that if two circles are congruent and having two equal chord, just like that, we have to prove that angle subtended by the chord at the center both will be equal. So these are the circle, both are congruent, which have same length of radius. That means this OA, O dash C are equal, OB and O dash D is equal and having equal chord. That means AB and CD is also equal. We have to prove that the chord subtended equal angle at center. That means this angle AOB is equals to angle CO dashed B. We have to prove this. So how can we prove it? Let's write that in triangle AOB and triangle CO dashed D, we can write that OA is equals to O dashed C because same radius, same, we can write OB equals to O dashed D, same thing, radius are same for congruent circles, and we can write that AB equals to CD because both are chords and it is says that equal chord. So from here we can write triangle AOB is congruent triangle CO dashed D by SSS criterion. So after that, because these two triangles are congruent, we can write that angle AOB is equals to angle CO dashed D because CPCT corresponding part of congruent triangle. That means from this we can find if two circles are congruent having same length of radius, having same chord, then the angle subtended by with the center will be also equal. Okay, hope you understand that. Now we will move to the next theorem. Okay, look at the board everyone. There are another two theorem, that is number 3 will be the perpendicular from the center of a circle to a chord bisect the chord. So theorem 1 is the perpendicular drawn from the center of a circle to a chord. Here chord is AB, O is the center and OA, OB all are radius. So if a perpendicular drawn from the center to a chord, it is bisect the chord. Bisect means cut in equal halves. That means this value of AM and MB will be equal. So from here, what should I say? That the perpendicular from the center to a chord will be bisect the chord into equal halves. Okay? And the theorem 4 is the line drawn through the center of a circle bisect the chord is perpendicular to the chord. And the number 4 theorem is this line has been drawn to bisect the chord, so it will be made perpendicular here, that is 90 degree. So how can you prove it? Let's take triangle AMA and triangle OMB in these two triangles, we can write that OA equals to OB. OA equals to OB because radius of the same circle. We know that a circle, all the radius will be equal. Next line we can write OM. This OM is a common side, right? OM is the common side for these two triangles. And next line we can write AM equals to MB because a perpendicular drawn from the center of a circle bisect the chord. Bisect the chord. That means this AM and MB will be equal. So from here we can write triangle OMA is congruent with triangle OMB by SSS criterion. So from here we can write angle OMA is equals to angle OMB, and both are on a straight line. So this is half to 90 degree, because if both are same and both is on a straight line and the straight line is 180 degree, so both have to 90 degree, that is CP CT. So what is the two theorem we have learned today? That is, if we draw a perpendicular from the center to a chord of a circle, then it will be bisect the chord. That means equal to halves, and it will make 90 degree there. Okay, hope you all understand that. If you have any doubt on this part, any question, you can ask me in the query section or next live class. Okay, that's all for now, students. Please stay at your home and stay safe.